let's say that I have the number 4 and I was to add a 0. What I did here was I multiplied by 10. And then I add another 0. What I'm doing is I'm multiplying by 10. And yet another 0, I'm multiplying by 10. Another way to write 4,000 would be to say 4 times 10. And I'm just simply counting the number of digits moving from here to here was 3. So 4 times 10 to the third power is 4,000. If we have the number 78,000, I can rewrite this in scientific notation. I would be moving the decimal 1, 2, 3, 4. We would want one entire whole digit to remain there. So what we would have is 7.8 times 10. And the number of spaces I've moved it is 4. So 78,000 would be 7.8 times 10 to the fourth power. For the number 9,600,000, to write this in scientific notation, I would be moving the decimal from here where it is, and it would be 1, 2, 3, 4, 5, 6. So I would have 9.6 times 10 to the sixth power. Now, when we have numbers, I'm going to just write a couple here. So I have 5,600, 74,000, 8,700,000. In every one of these cases, if I have a number that's greater than 1, I want to use this digit, so I write a 5. Then I have the decimal here, so I'm moving it 3 spaces, so the decimal's here, then I put the 6, and 10 times 10, and the exponent here is going to be the number of digits that I move it. Let's look at the next one. So the first digit is 7, then I put a decimal, the next digit, 4, and how many decimals do I need to move from here to here is 4, so it's times 10 to the fourth power. And then here, my first digit is an 8, and I'm going to put point the second digit. And in order to move to here, I'm going to go 1, 2, 3, 4, 5, 6, so it's times 10 to the sixth power. Now this applies only to numbers that are greater than 1. Let's look at what happens when we have numbers less than 1. Now for values that are between 0 and 1, or to look at this, numbers that are less than 1, so it's between 0 and 1, let's look at 0.0048. Since the decimal has to be moved to this direction in order for this to be my first digit, so I would have 4.8. So the decimal is going to go here. I would have to move 3 spaces. But since I'm moving in the other direction, it's times 10 to the minus 3 power. Let's look at a few more examples of that. So here we have a 5, and I have a 9, so I'm going to have 5.9. In order for the decimal to be here, I would have to move 1, 2, 3, 4 spaces. So it's times 10. Since I'm going to the right, it's to the minus 4 power. And then on this one over here, this would be my first digit, so I'd have 2.4 times 10. And to put the decimal here, I would move 2 spaces, so it's to the minus 2. And then for this one over here, this would be my first digit, so I have 4.3 times 10. And in order for the decimal to be here, I would move 1, 2, 3, 4, 5, 6. So it's to the minus 6 power. Here I've written 4 numbers that are in standard form, and I would like you to write them in scientific notation. I encourage you to pause the video right now and try to do that. So to write the first one, I'm going to look at the 5 over here. I write that as 5.9. And then how many digits do I need to move to here? And that's times 10 to the third power. The next one is going to be 6.8. And if the decimal is here, I would have to move it 4 spaces. So it's times 10 to the fourth power. In this one, I have the digit 9, so 9.2. To move the digit to here, I would be moving it in the opposite direction, so it's times 10 to the minus third power. And then over here, I have 3.7, and to get it to here, I would move it 2 spaces, so that's 10 times 10 to the minus 2 power. Here we have numbers that are written already in scientific notation, and I want to convert them back to standard form. Well, I start by taking the 4.8 and I write that over here. I'm not putting the decimal, so I just put 48. And what this tells me is it times 10 to the 6th power. If the decimal was here, I want to move it 6 times. So that would be 1, 2, 3, 4, 5, 6. You can check it by, how would you get 4.8? You can check it by moving the decimal to the left here. 1, 2, 3, 4, 5, 6. This one's correct. And then I write 5 and the 1. I don't put the decimal here. And then I have 10 times 10 to the 4th power. So if the decimal was here, I want to move it 4 spaces. 1, 2, 3, 4. To check it, move the decimal the other way. 1, 2, 3, 4, and you should get 5.1. So this one's now correct. Now this over here, for the 3.6, I'm going to have to move the decimal 3, but instead of moving the decimal to the right, I'm going to move it to the left. So I'm going to put 3.36. I'm not going to put the decimal here. And it says I have to move it 3 spaces, so it was here. 1, 2, 3, and I put the decimal here. To check it, I move it 3 spaces the other direction. 1, 2, 3, and I get 3.6. So this one's now correct. And then our final example here, I have the 1 and the 1.8, so I'm just going to write 18. And then I want to move the decimal to the left 2 spaces. I was here, so 1, 2. So I have a decimal and a single space. To test it, I move 2 spaces, and I get 1.8. So this one's now correct. And the last thing that we'll take a look at here is taking a number with all of these digits and rounding it so that our scientific notation would be simpler. So I want to round in this case to the 100,000ths. And so I'm going to look at the very next digit, and this entire thing can go down to 0. So rounded, this would be 1,700,000. And then this would be my leading digit, so I'd have 1.7. And then I count from here 1, 2, 3, 4, 5, 6. So this would be 10 times 10 to the 6th power. If I had 2,890,2,621, what I want to do rounding this one off, I'm going to round to this digit because I want to have 2, and I look at the next digit. And since this one is above 5, I would round this one up. So this would become 2,900,000. So over here, I would have 2.9 times 10, and 1, 2, 3, 4, 5, 6. 10 to the 6th power.
That was easy.